as we get into this part here, remember, we will test on Wednesday. That gives us a day, basically a better part of a day and a half to get through 8-6, which is no big deal. So remind everybody that's gone, their test is still Wednesday. So here's what we've got.
Can you go back?
We're solving log equations.
What's the name?
Log equations. So there's going to be about 5 or 6 different types of equations that we're going to be working through today. And with each one of them, there's little tricks in how to set them up. For example, in this first equation here, in order for us to solve this problem, you can see that I have set this up in such a way that what do you need to try and do? Get a common base. Great idea. Where would you have ever gotten such an idea? Now, when you're looking at something like this, where you've got 2 bases raised to exponents and your variables are within the exponents, what you want to do is get common bases here. So how do you get a common base between a 4 and an 8? No. Remember, what I'm dealing with bases here, I want to have a base to an exponent, all right? Rewrite 4 with the same base as an 8. 4 is the same thing as what? 2 squared. 8 is, okay, so this is the same thing as saying 2 squared times 3x equals 2 cubed times x plus 1. Everybody see that? Now, what happens next is pretty cool. Are those the same bases? What's that? Not so much that they cross out, but since these guys are the same bases, what you're able to do now, is just take the exponents and solve them. So what's 2 times 3x? Bless you. Equals 3x plus 3. So by creating the same bases, you're able to get the exponents out of the air, if you will. Okay? They're able to drop down, and then you wind up with a very simple 1 or a 2-step equation. So you get 3x is 3. What's x? 1. Okay? And then what would you do to see if you were right? You doing electrical work now, Dad? You're doing electrical work now? Yeah, just substitute back in. So you can check it this way as well. 4 to the 3 times 1, does that equal 8 to the 1 plus 1? So does 64 equal 64? Yeah. So it's very easy for a lot of these problems we would go back and check. All right? All we did there was just create the same base. Remember, when you're dealing with these bases, you're looking at, a lot of times you're going to be dealing with 2s, 3s, and 4s. They're relatively simple to work with, and the only thing that you guys will mess up on, because I know you, when I did this 2 cubed part here, a lot of times what you'll forget to do is distribute to that second term. Make sure you distribute to both terms. Okay? That's usually where you guys will just make a simple error. All right? Let's try some more. So I'm looking at these two guys. 9 to the 2x equals 3 to the x minus 6. What do you think the common base is going to have to be between a 9 and a 3? 3, good. So which one do you have to rewrite? The 9. Excellent. So 9 is the same thing as 3 to what power? 3 squared. So this becomes 3 to the 2 times 2x equals 3 to the x minus 6. What do you wind up with then? What's that? Because this is the exponent. This is the exponent up here. It's not, because once you get these bases to be the same, not so much cancels, but it drops the exponents out. That way the exponents have to be the same. Okay? That's how you're setting this up. As long as you get the identical bases, your exponents can be set equal to each other. That's kind of the rule for this style. Then bad things happen. There's going to be problems like that later. We'll get to it, okay? It's not always happy, fluffy clouds and kittens and puppies. You know, sometimes that limit doesn't exist, but... Did you get -2?
Yeah.
Try the other one real quick, see what you get. Shouldn't be that bad. Gee, I think everybody's gone today. So, I'm assuming you guys got 2 to the 3x equals 2 to the 2x minus 2. Can you distribute out?
Yeah.
I just wrote it in one step, that's all. What?
I thought it would be like 6x equals x minus.
No. You want to get these bases the same. Okay? No. Rewrite, because this is already a base 2. 4 can be written as a 2. You can't square this to turn it into a 4. It is, but you want to rewrite this guy to go here. You want to work to the easier base, all right? Because if you square the other stuff, it doesn't work. All right? You have to work within the bases that you have. So you wind up with a 2 to the 2. That's what I was saying, where you get 3x equals 2x minus 2. You got -2 again. Okay? All right. So like I said, it's not always super straightforward, super duper easy. Sometimes things get a little more complex. Like this. So now what we wind up with, this is 2 to the x equals 7. Sorry, that didn't look that great when I typed it in. It's 2 to the x equals 7. Well, in order for us to be able to get that exponent out of the air, if you will, remember some of the properties of logarithms. When you deal with logarithms, if you have log base b, some b to the x, do you remember what happened there? Yeah, and what happens to the exponent? Yeah, it's by itself. It kind of drops out. So this winds up equaling x, right? So what log would I have to take on the left side to get the exponent out of here? Log of what base? Log base 2. So what you have to do here is take the log base 2 of 2x of both sides. So now what happens is, by taking the log that have the same base, your exponent drops, and you're going to get some weird decimal. Did you change base? Okay, just want to make sure. Like I said, you got to make sure you change your base when you're doing these things in the calculator. Remember, your calculator will do that change base formula. Or if you want to use the long version of change base, you can as well. Log of 7 divided by log of 2. It's not like it's that difficult. Okay. So you should get, what you guys get? 2.81?
Could you just leave it in log 2 base 2 7, or do you have to go?
It depends on what the question asks. If it asks you to round from 2 decimals, go 2 decimals. If you leave it like log base 2 7, if it doesn't say it, that would be okay as well. All right. So on this one here, 3 to the x equals 14. What do you have to do the log for both sides?
Log base 3.
Excellent. So you can see how quickly these can go, right? So you have the log base 3 of 3 to the x is log base 3 of 14. And you get some number. Okay. Not so bad so far. That is waiting for the world to end. We all okay on this style, right?
So when you do exponentials, like how do you determine when you make it equal?
For this part?
Yeah. Like, one part?
Yeah, this is the answer then. But whatever the decimal is.
Yeah, but like I suppose you have to like cancel stuff out.
Oh, remember log base 3 of 3 to the x. Since see how the two 3's are the bases? If those are identical, the exponent falls. That's the property of this here, of this one. Okay? That's what we're trying to make that look like for this style. Alright? I'm not going to bother with it. Alright, so let's go and do some more. Ten to the 2x minus 3 plus 4 is 21. 10 to the 2x minus 3 plus 4 is 21. Subtract the 4. Good. Very good. Did everybody hear what Jan said to do next? Log base 10 of both sides. You can write just log, that's fine. Now if you log both sides, you wind up with 2x minus 3 equals the log of 17. Do we all agree that the log of 17 is going to be some decimal? Okay. Can we wait to put that in the calculator until we move the rest of this over? Is that okay? You might be off by a little bit of rounding. I prefer that you I would prefer that you leave this in the answer before you go any, once you have log on one side. That way I can see that you know how to solve the rest of it. Because, it'd be very simple to type in something wrong. You know what I mean? Do we all agree you add 3 and divide by 2?
Yeah.
So we get x is going to equal log of 17 plus 3 all over 2. Now, in your calculator, you have to be careful how you type that. Hopefully it's loading. Loading. There we go. When you hit the log button, since you don't have to worry about changing the base here because it isn't a base 10, when you hit the log button on your calculator, does a parenthesis open up right away, I think?
Yeah.
All right, make sure you close it before you go any further then, okay? That's usually where you guys will screw up. So let's see, it was log
Nothing.
plus 3, then hit enter, divided by 2. 2.16, or sorry, 2.12. Okay? Everybody get that? All right. Try that one. 10 to the 3x minus 4 is 0.1. done math in a couple of days.
I'm not giving one, so yes.
Good idea. Let me see what I did. Isn't this the same thing as this? Yeah, it's if you guys took the log of both sides, right? You did 3x minus 4 is the log of 0.1. If I got the same answers, I'm going to get. Did you get the same answer? Uh-oh. Did you see what you did wrong?
Yeah.
Okay. Because you're sitting next to somebody else. Even more fun. I'm not even worried about labeling what this looks like. Look at that. Isn't that awesome? Log base 3 of 5x minus 1 equals log base 3 of x plus 7. Why do you say that? They have the same log base, okay, so what do you think your next step is? What happens here, guys, is since the fact that you have the same log base on both sides of the equation, it's the same idea as when you had the same bases with the exponent parts. If you were in the same bases, the exponents fell. Since in this case you have the same log bases, the junk in the parentheses kind of just stay there. Does that make sense? It's kind of the same principal idea. So now you wind up with something very simple to work with. 4x is 8, x is 2. Right? Now, with any luck, 10 minus 1 is? 10 minus 1 is 9. And 2 plus 7 is? So log base 3 equals, log base 3 of 9 equals log base 3 of? Should be the same number, right? All right? Do this one then. It's not a separate sheet. Hold on. Do this one. This one's going to take a little bit more thinking, I should say. After that, we're all kind of going, uh-oh. So we all agree that this happens. No! Set aside equal to 0 and factor it. What times what's negative 2 you add together to get negative 1? Negative 2 and 1. What are your zeros? And what do you have to do then? And check them. Don't get mad. Get even. Didn't the housekeeper from Brady, well, it was Alice, right? Yeah. Didn't she do the commercials for Don't Get Mad, Get Glad? A little before your time. So a little. Yeah, whatever. So just double check. 2 plus 2 is 4. 2 squared is 4. Negative 1 and 2 is 1. Negative 1 squared is 1. So this does work out. Okay. You always want to just quickly double check, make sure you don't have one of those extraneous solutions. Don't freak out, guys. This does happen. Okay, this will happen. All right. I haven't lost you completely yet, have I? You guys seem to be flying through this, so I'm pretty happy about that. Does it get harder than this? Of course it does. We're not even half. We're almost halfway done. What's up? Not for stuff like this. You're not going to worry about changing your base. Okay. Set up that one real quick. Solve it. Shouldn't take you very long. You can probably look at it right now and tell me an answer. I'm going to move you over here. That way you can't look out a window. And you don't sit and talk.
I don't. She was out today.
You guys are so mean at this. Seriously, if another person on the bed, you just write to each other. I'm telling you, this place freak out. You want to know you. I don't think I want to know you anymore. I'm frightened by you two. Hey, what's your answer for x? 15. Everybody see why that happens that fast? Same base as it drops, 2x plus 15 is 3x. Are we okay? They're arguing, so I just want to make sure. Well, here's where things get interesting. No. No. We've got stuff to do. Don't worry about all the words up there. Basically what we wind up having to do here is called exponentiating. Okay? Now, this kind of goes along with the idea of what do you do when all else fails? In this case here, we don't have the same logs on both sides. We don't have something that has the same bases on both sides. We have nothing in order for us to make this work. So this is the whole idea of when all else fails. Yeah, when all else fails, probably. Or ask tomorrow for me to do in class. Don't give up. So what we want to be able to do here is get the same, we want to be able to get rid of that log. I want to get rid of this log base 5. And in order for us to get rid of that log base 5, we have to create it to become its own exponent. Because remember, when you had b to the log base of x, what happens? The b's drop and you're just left with x here, correct? We're kind of doing the exact same scenario here. What I'm going to make this 5 to the log base 5 of 3x plus 1. So what do I have to do to the other side? 5 squared. What I'm doing there is that I'm creating an extra base, I guess is an easy way to say this. By doing that to both sides, this base and this base simplify themselves out, and you're left with 3x plus 1 is 25. Remember, the rule is base to the log base just leaves you whatever the junk left of that x value. All right. All we're doing is just reusing the simple properties of logs that we did at the very beginning of the chapter, with a lot weirder looking stuff. It's not multiplying, but yeah, you're raising it, you're putting that base in front of it. Yeah, that's really all it is. Okay. So in all honesty, it's not that it's really complex, but I've shown you guys, what, 6 different methods that happen. You just have to figure out which one you're using. Okay. To get x is 8. Let's do another one like that. In this case here, we have log base 2 of x equals negative 1. So what are you going to do to both sides? You put the 2 in front. And what do you wind up with? Very good. X is 1/2. Remember, negative 1 power just means it's just not happy where it is. Send it where it's happy. Apparently a lot of people today are happy at the art groups. I think so. I haven't been there forever. Okay. Really isn't that scary, is it? No, the art institute usually isn't very scary unless you walk into one of the weird rooms. Do that one. Think about what you have to do here. Just kind of putting everything together now. What's that? Probably. What do you think you got to do first? Good. We all agree you got to subtract 15, right? Yeah, we don't want to collapse or any of this stuff here, okay? Remember, why can't I collapse anything? If you want it, all right, so Taylor's like, ooh, all right, Taylor, I'm going to put you guys on the spot. Why can't you collapse these? Why can't you condense them? Okay. Why can't you? They don't both have the same, there's no log basis over here. Yeah, they don't have the same log basis. Anyway, so you wind up with 2 log base 2 of x is 16. Now what do you do? Divide, okay. So log base 2 of x is 8. Now what?
Log base 2 is 8.
What am I doing? Now I go 2 to the log base. Are we okay up to there?
Yeah.
Okay. Now, this is the same problem as that. So now all you do is just take 2, raise into those exponents. 2 log base 2 of x just becomes x, and 2 to the 8th power is? Because that's how you undo that's how you're undoing this log. Remember, you gotta remember this. That's what I'm using. I'm using that property over and over and over again. Okay? Sneaky? How's that sneaky? What are you going to do? It's base 10, so what do you do?
3 to the 10th power.
Yeah.
10 to the 3rd power.
Was that 1,000?
Yeah.
Remember, if you don't see a base here, it's a base 10. Don't get angry at it. Just want to make sure we're okay. I'll give you guys homework after this one. I just want to make sure you have plenty of examples of this, that's all. Log base 3 of 2x minus 1 equals 3. Because you knocked it over. I watched you do it. It's on tape. Do we agree so far?
Correct. Yes. Yeah. 28.
Sorry, I was already solving it all out. Okay. And then you wind up with log base 3 of 27. Does that equal 3? Always check them. Make sure they're not getting into strange solutions. Okay? I think that's all. Oh, real fast. Now I'll let you worry about that. Do those. Once again, all I did here, ladies and gentlemen, was make sure and go through the problems themselves that don't deal with E, that don't deal with natural log. It just looks like a lot, but it's very similar to what we've just done in class, okay? Can we pause this?